preliminary discussion of Jack Parker Holder's PhD thesis. We're going to discuss it a little bit more in depth, but I want to start here just because it's also a big endeavor, so it's probably better to split it up. So what are we doing here? We're talking about, we often talk about papers in this podcast. This time we're talking about a PhD thesis, which is relatively rare. We don't actually go that deep. But in this case, I think it's worth it. I think Jack Parker Holder's PhD thesis, which is about open-ended learning, about the idea of creating agents that not just adapt to the environment, but also have a system embedded that explores different types of environment. In other words, learns about the environment and therefore has no priors even as the environment is concerned. So a little bit like Mu Zero, where they learned to play Go without even giving the rules of Go. So the system just learned about the optimal movement within the environment that was given in that particular case. So why are we doing all this here at Orange Capital Partners? Our purpose is to give people a sense of what it feels like to run a hedge fund. Now, we're very highly invested in AI. I think open-endedness, open-ended learning, continuous learning, as Richard Sutton talks about it, as Jack Parker Jack Parker Holder and his cohort talk about it, also Marcus Hutter, which is cited in this PhD thesis. I think all these sort of movements are going in the same direction. What we want is learn from experience. That's the key. We want to learn from experience. I mean, I can even go back to Ralph Waldo Emerson and his poetry, which is, the sort of the philosophical foundation of, I would say, the United States as a country. Now, that's, of course, as far as philosophy and social environments are concerned, but I think it's the same idea here in AI. We're building an intelligence that is not confined by human knowledge. We're building an intelligence that is not learning how humans learn, but it's learning from experience, and that might sometimes overlap with how humans learn and sometimes not. That's the fundamental idea. So we're at this point, the first 5 sections of the thesis. So we're going to talk a little bit about this. We also want to mention a few things about the markets. This is not even on podcast. It's September 8, 2025. This is Krim Delco. For the year, we are down 7%. The market's up 9.5%. We're underperforming by 16.5%. Just real quick about the markets in general. We have a sort of a lowering interest rates type macro environment. So there's good performance in the markets. Tesla specifically, we've seen some interesting development as far as Musk's compensation is concerned. I think what's most important about Musk's compensation plan is not the plan itself, but it's kind of like a model that people are using to model the company. And I would say that in this compensation plan, about 2/3 of the metrics, particularly the EBITDA, 400 billion of EBITDA, I think about 2/3 of that is realistic. 1/3 is more sort of in the upper range of the distribution. So it's not really in the, you can't really make it work with the current model unless you assume massive deployment, let's say, of Optimus or high margins for Optimus, or maybe you can have trucking, robo trucking could be an interesting actually avenue of high returns. So you need to come up with something along those lines to make it justifiable. But I think that's fine because it's also meant to be a staged plan with a maximum payout, and we don't necessarily have to assume maximum payout here. I think as far as NVIDIA is concerned, I want to say a few things. NVIDIA has been selling off since the earnings call. I think there's 2 things here. One is their growth is just, it's good growth and there's nothing wrong with it, but it's not accelerating. So I think people are taking a pause because the competitive pressures are ramping up, particularly after the Broadcom call. We had some issues or some fears that there's too many ASICs developments and that there could be an issue with NVIDIA. The way we see this is that anybody who can and will invest in massive deployments of almost all the big NVIDIA platforms, particularly Blackwell and Vera Rubin. So there's no fear about that. You will see a lot of ASICs development just because there is also a lot of bespoke type infrastructure to be built. I mean, that doesn't mean that people don't want NVIDIA. I think you want to diversify your infrastructure, and you want to have a couple of sort of coals in the fire here. But overall, I guess my point, my conclusion here is that we think NVIDIA is the risk there is to the upside, and here's why. And actually, Jack Parker Holder's thesis is one of the foundations of why we believe that this continuous scaling and the bit lesson and the scaling laws will continue to be just the driver of AI, because we're going to keep learning from experience. And Jack Parker Holder's PhD thesis is a fundamental backbone of this ideas. It's not the only one. Richard Sutton works on this, of course, and then Marcus Hutter, who has been cited in Jack Parker Holder's thesis, is also, I think, working on the same, going into the same direction. What we're dealing with here is that we're trying to predict strings from experience. We are trying not to confine our models into any priors. We're not even trying to give them environment. So when we're teaching a robot how to walk, we don't want to tell the robot what kind of surface it's walking on or what kind of obstacles it's going to see. We're going to try to build flexible models that dynamically change the environment while the agent is learning. So we have two, if you will, we have two optimization problems here. One is the agent moving within the environment, and the other is the environment itself. And of course, that's pretty challenging, right? And in particular, what's challenging here is two things: exploration versus exploitation. That's one thing. And the other is you want to keep learning continuously. That's the Richard Sutton side of things. So Jack Parker Holder, I think, focuses more on the environment per se. He's not focused, at least not, again, we're about 2/3 into the thesis, so this might change. But what we're seeing so far is he's more interested in the conceptual foundation of the model, and the continuous learning part is not being explicitly mentioned here yet, but it could come. But what we mean with that is the following. Well, first you have to set up a conceptual framework that allows an agent to learn. So the robot is walking on a surface, and then that surface is changing, right? That's the key idea. And Jack Parker Holder now is working within the Genie project at Google, which is building different worlds so robots can learn in those different worlds. That's the many-world interpretation of AI, as I coin it. So, which is kind of an interesting side note here, that we have the many-world interpretation of physics, and we're now morphing into that same world in AI, where we're building many artificial worlds in which our agents can learn, and then we're just doing the sim to real transfer. That's, in my opinion, how particularly embodied AI will be able to scale with the scaling laws that we've seen so far, and actually continue to scale. And that's why we believe NVIDIA and also Tesla have lots of upside, because they're on this bandwagon. What does that mean? That means that we have to, build a model that is able to consume lots of real-world data, transfer it into a behavioral model. In other words, using RL to actually, create some behavior. But we also want to change the environments in which that behavior is being trained, so the agent can, in principle, be prepared for all kinds of environments. So we have slippery roads, we have up, we have down, we have obstacles, and we have many environments in which the agent can learn. Now, one of the key concepts in section 5 of the thesis is diversity, right? What you don't want is a convergence. You don't want the model to reward hack itself into a convergence. So, for example, if, just hypothetically, if I want to, decrease entropy for the agent, and that's my ultimate goal that the agent is pursuing. In principle, the agent could, for example, create an environment where nothing changes, right? And then have minimum entropy. You don't want that, right? So you want to make sure that the agent is continuously learning in a diverse set of environments with diverse set of behaviors. And that can be done mathematically through determinants. Determinants in general define the diversity of a matrix. So there's a mathematical application to this problem, which I think is interesting, just as a side note for anybody who is debating whether they should understand linear algebra or not. I can tell you, I've seen, we've spoken about this before in one of the previous episodes. If you want to understand NVIDIA, if you want to make money with AI, take a fundamental linear algebra class. It's going to help you more than all the news and all the X posts and whatever else you're reading. Understand linear algebra from its fundamental core, because that's what AI is all about. Linear algebra equals AI. AI equals linear algebra. So this is just as a tangent. Back to this thesis. So again, we're now getting to the section of learning world models. We haven't discussed, we're not going to discuss this here. But so far what we've done is we went through the reinforcement learning concept, and then we've applied open-endedness or an open-ended environment design, or unsupervised environment design, UED, where you continuously, stochastically change the environment and also increase the potential action space based on the change of environment. And I think this is where this is what excites me so much, because I think as a second order effect of Gen AI, we're actually going to have real world AI coming out of this, because real world AI is going to be predicated on the ability of agents to learn in diverse environments, and that is the path towards that. That's going to be the path. So you create many worlds in which agents can learn, and that's what this thesis is really fundamentally based on. Again, I think most importantly, so far we're into the first 5 sections. I think unsupervised environment design is one of the key factors, and diversity is the other key factor, on top of all the other things that come with reinforcement learning and all the problems and upsides that come with reinforcement learning. The one thing Jack Parker-Holder doesn't talk about too much right now is continuous learning. So the ability to define your own problems and then solve them and adapt your own problem space to the environment space. The things along those lines, they might be discussed again. I'm not sure about that, but of course, we also see a very nice overlap here with Sutton. I think, again, Sutton and Jack Parker-Holder and the Genie team, these are all similar type of problems, I think. It's just they're coming from different aspects. Sutton comes from the continuous learning aspect. The people from Genie come from the sort of create many worlds aspect. But the idea is the same. We want to have lots of diversity, lots of data, and lots of environments in which we can train our behavior, so then the actual real agents in our environment, that is the environment that we actually live in, the world, the nature, can be as fundamentally intelligent as possible. Thank you.